In this video we're going to look at some more methods for solving differential equations. The first is a method for solving linear differential equations known as the integrating factor method. These are the sorts of questions you might see. We're going to use it to solve the second of these questions. We've got dy dx plus 4 over xy equals 0. Now to solve this we first find what we call the integrating factor, and we solve that by taking the coefficient on y, integrating it, and then taking the exponential of that expression. So we take exp of the integral of 4 over x dx, or exp 4 log x, which is just equal to x to the power 4. Now we multiply through by that expression, and that gives us an equation x to the power 4 dy dx plus 4 x cubed y equals 0. Now the advantage of this is that we can write this expression using the product rule for differentiation as dx to the power 4y dx equals 0. So we simplify our differential equation. We can now integrate that relatively easily, and we get y multiplied by x to the power 4 equals a constant of integration, or y equals the constant of integration c divided by x to the power 4. And that's a neat way of solving this type of equation. The second method we're going to look at is the method of undetermined coefficients. This is a way of solving non-homogeneous differential equations which have got quite complicated expressions on the right hand side. We're going to look at this equation here, dy dx plus y equals x 2x. Now we can write that alternatively as dy dx equals minus y plus e to the power 2x. We can solve that, like many linear differential equations, as the sum of a complementary function, the solution to the homogeneous equation, and a particular integral. The complementary function is easy. We've got y of x equals c e to the minus x. The difficult bit comes in the particular integral. Here we're going to try a function of the form y of x equals a e to the power bx, and our choice is determined by the nature of the expression on the right hand side of our original equation. Now if that is a solution, then we have from the equation b a e to the power bx plus a e to the power bx equals e to the 2x, or rearranging we have b plus 1a e to the bx equals e to the 2x. And here is where we use undetermined coefficients, because by equating coefficients on both sides of this equation we can solve for a and b. We immediately see that only b equals 2 satisfies the equation. If this is the case, we have 3a equals 1 or a equals 1/3. So that means our particular integral can be written as 1/3 e to the power 2x. And our solution, our general solution for the differential equation, is the sum of the complementary function and the particular integral. So in this case what we'll get is a constant of integration c multiplied by e to the minus x plus 1/3 e to the power 2x. And we can confirm this by differentiation.